All right. Having said that, let's talk about this. Let's see what it says. It says, all right, guys, we know how to find areas. For the most part, if a boundary or region is defined by more than one function, we can partition the region into subregions that correspond to the function changes and proceed as usual. Finding area. So this you already know. So it says, find the area of region R in the first quadrant that is bounded by y equals square root of x and below the x-axis and the line x minus 2. So they want the area. You see this? Mine is shaded in gray and it's shaded in blue. So I want that area. So notice for the area shaded, well, it's shaded in gray, but I'm highlighting it here in red. For that in red, and I'll color code it, that is the area under the square root curve. This is the square root curve from 0 all the way to 2. So integral 0 to 2 of the square root of x, that's what it says right here, dx. And then I'm going to use a neutral color plus, and then I'm going to do this in blue. How do I find area under the curve? Well, remember that all these are just Riemann sums. Here's my rectangle. This is delta x. See? So, and I'm just adding up a whole bunch of rectangles. How do I get the height of this rectangle? The top curve here minus the bottom curve here. Do you guys see that? So I'm going to go integral from what's my x value? What's my lower limit for my x value? What's my upper limit for my x value? And then I just do upper minus lower. That's how you find the height of that function. So upper, y equals square root of x, minus lower, x minus 2. Does everyone see how I got that? Yes. Okay, and then all this times your delta x. You got to have your differential. That's how you find area of one rectangle, and I'm adding an infinite amount of them. What's up? Oh, because I'm just doing upper minus lower. This, how do I get my y coordinate here? I put in the next value there. So upper minus lower, and then I put that in parentheses so I can distribute that negative. Are we cool? Okay. Does that? This one? Yes. This at y equals 0, or you can just anything minus 0. You know what I mean? Usually, you can say area of the curve from that to the x-axis, but it's understood. There it is right there. Y equals 0, so that minus 0 is the same. Good question. Keep them coming. Keep them coming, guys. All right. We already have it done. In the beginning, we're going to have to do it by hand. And then don't worry, we have calculators. Eventually, we'll just type it in the calculator. I'm going to distribute this negative like this because I want to do this by hand. So I'm going to go to a neutral color, purple here. I'm going to go integral 0 to 2 of square root of x dx plus integral 2 to 4 of square root of x minus x plus 2 dx. The dx is known to be the end. If it bothers you, like child, it bothers me. Okay, put a parenthesis. I remember a long time ago, I had a kid that they needed to have the parentheses there. That's fine. But make sure that you understand that in textbooks, sometimes they won't put those parentheses because it's understood that the dx is last. Are we okay? All right, check it out. Antiderivative, that's x to the half. So x to the half plus a half, I'm going to have 3/2 divided by 3/2, which is the same thing as 2/3. I'm going to put this in a bracket. I'll put a lower limit of 0, upper limit of 2. Okay, that's what I'm doing for that one. Plus, bracket again. Antiderivative of square root of x, again, is 2/3 x to the 3/2. Antiderivative of x is x squared over 2. And antiderivative of 2 is bracket 2 in the bottom. That's a 2. Sorry, I just couldn't read my handwriting. That's a 2, and the top is a 4. You're done with calculus. Now we're just doing arithmetic. So let me take this one. I'm going to use my red one to indicate that I'm doing the red one here. And I'm going to do that up here. Is that okay with you guys? All right. So upper minus lower. Well, I guess it doesn't matter because any 0 raised to any power is just going to be 0. Well, I shouldn't say any power because 0 to the 0 is something. It's undefined. It's indeterminate. But that is a special case. We're not in BC, so let's not worry about it. Anyways, here we go. 0 to the 0 power is indeterminate. It's undefined. It's not a thing. But when you do a limit or whatever, that might be something else. But that's something you'll see what I'm talking about next semester or when you take Cal 2. You'll see what I'm talking about. Oh, that's what Chavez was talking about. All right, here we go. 2/3 parenthesis 2 to the 3/2. You don't have to put that in parentheses if you don't want to. I'm just putting in parentheses here so it's easier to figure this out. Guys, the 3 means the third power, and the 2 in the bottom of that exponent means square root. They both have equal weight. Chav, what does that even mean, equal weight? It means it doesn't matter which one you do first. You're going to get the same outcome no matter what. You guys know what I mean? So I think this is just my opinion. It's your opinion. I think 2 to the third power is easier because I don't know what the square root of 2 is. It's irrational. It goes on forever. So here's what I do. So here's that 2/3. That 2/3 is this one. And then parenthesis 2 to the third power. So 2 times 2 times 2, that is 8. And then I'm going to do the square root of 8. Well, the square root of 8, remember that 8 is 4 times 2. So 2 square root of 2. So 2 times 2 square root of 2. And then I have this 2 here. 2 times 2. So 4 square root of 2. That's what I got for that. So there it is. That's that part. Plus, okay, this one here. Look, I'm putting it in blue, so I'm trying to color code it. Where do I do it? I guess I'll do it down here, or I'll do it right here. I already know, so big parenthesis, I already know what this one is that I'm circling. Do you guys see what I'm circling there? Well, I don't know it for the 2, but I know it for the, I don't know it for the 4, but I know it for the 2. So I guess let's try the 4 now again. So 2/3, parenthesis 4 to the 3/2. In a little bit, we'll figure out what that is. And then minus, let's see, 4 squared is 16. 16 divided by 2? 8. Plus, what's 2 times 4? 8. So there it is. That's the upper. Minus, and then here it comes, parenthesis, the lower. I know this one. Yeah, that's what I meant to say. I know that one. If I plug in a 2 in there, well, didn't I just do that a little while ago with this one here in purple, or the red one up here? Isn't that the same thing? So I know that one. I'm going to get 4 square root of 2. Does everyone see where I got that 4 square root of 2? What's up? Yeah, ask me.
Where did the 3 go? In the first part.
In red?
Yeah.
When you divide it by 3/2, it's the same thing as multiplying by 2/3. Oh, did I mess up? Oh, yeah. There's a 3 there. There you go. There you go. Thank you, miss. I mean, I actually would have gotten it still correct because I'm just writing the same thing, and when I distribute the sign to the site, they're going to cancel. So I would have gotten it correct by luck. It should have a 3 in the bottom.
Okay, I was like,
No, you were right, miss. You guys stop me if I'm wrong. Does everyone see where I messed up, but now I fixed? Okay. Thank you, Morales. If it weren't for you, I would have gone crazy if I would have uploaded this to YouTube with that error. All right. I think we're still good. I don't see any issues. Okay, let's plug in a 2 right here. 2 squared divided by 2. So minus 2. And then 2 times 2. Not everyone at the same time. 4. Oh, you did? You said 4? I didn't hear. Sorry. All right, so let's see what this is. I'm going to come back down here. And let me see. I'm going to put a bracket. And here's what I have. Okay, now this one, you see this one here? I can do the third power first, or I can do the square root first. 4 to the third power, I know what that is, but I don't want to, well, I guess it doesn't. In this one, it looks like they're both the same. I still think the square root is easier to do when it's a 4. What's the square root of 4? 2. 2 to the third power? 8. See? You would have gotten it the same way. Look, 4 to the third power. 4 times 4, 16. 16 times 4, 64. What's the square root of 64? No. 8. Square root of 64 is 8. So we would have gotten there anyways. What is 8? What is 8 times 2? So this is 16 over 3. Let me write it in blue. 16 over 3. Does everyone see how I got that? These 8s are 0 out. Are we still okay? And I'm going to distribute this negative, and I'm going to combine these two right here. So minus 4 square root of 2 over 3. Here's that luck that I was telling you about. They were going to cancel anyways. Negative 2 plus 4 is 2, but when I distribute the negative, minus 2. Are we okay? All right, I'm going to go back to my neutral color, which in this case was purple. I think that's what I said. So here it is. I'm just dropping the brackets. There's no minus sign anywhere. So 4 square root of 2 over 3 plus 16 over 3 minus 4 square root of 2 over 3 minus 2. What's going to zero out? 4 square root of 2 over 3. Those zero out. And then I finally have 16 over 3 minus 2. And then this 2, I'm going to turn into a denominator. So I'm going to turn that into 6 over 3. I'm going to turn it into a fraction. Sorry, guys. I'm really tired. 16 over 3 minus 6 over 3. What's my final answer? 10 over 3. That is the area of that shaded in red and this shaded in blue. Yay or nay? Okay. All right. Does everyone have a calculator? You have a calculator? All right. Reset your calculator because there's a lot of junk in there from pre-cal and all the other classes. Second memory 712. Is everyone okay so far? All right. So here's what I'm going to do. I'm going to type this into y1, y equals square root of x. So I'm going to take my calculator, and I'm going to go, I don't see my mouse. There it is. There it is. Nope. See, it disappears. There we go. Y equals, and then I'm going to type in square root of x. That's my y1. And on y2, I'm going to type in the linear line. What's my linear line? X minus 2. All right, there it is. I'm going to go to my home screen, and I'm just going to type in math 9. I'm going to type in exactly how it looks on my little guided notes here. 0 to 2. And I typed in square root of x and y1. So I'm going to go alpha trace y1 minus alpha trace y2. I put an x here and I push enter. And there, oh man, I'm all messed up. I'm not. Yeah, I don't know what I'm thinking. It's because I'm thinking about stuff. 0 to 2. Here we go. Just alpha trace y1, just y1, x, and then the next one plus math trace alpha trace. Let me go over there before I mess it up. Sorry guys, it's been a day. Alpha trace y2. The math. I need to put math first. I need to put the integral first. Math 9 from 2 to what? 2 to 4. What are you going to say, Kyle? Alpha trace y2. And put an x. All right, bam. Oh, yeah. Why did I did the same mistake right now, right? y2 minus y1. Or y1 minus y2. Alpha trace y1 minus alpha trace y2. Sorry, guys. My brain's all over the place right now. I'm thinking about stuff that I need to finish. All right, there we go. Yeah, let me focus on this because I don't want to make mistakes. I don't want you guys to be confused. 3.33333. You see that point, that 544? That's because the calculator is like, the algorithm of the calculator is doing like something where, okay, this approximation is good enough, so we stop. But notice the first 3 digits after the decimal are the same as 10 over 3. Look, 10 over 3. If I type in 10 over 3, the first, look at that. 1, 2, 3, 4, 5, 6. The first 6 digits are the same. Or yeah, Gonzaga, are you ready on the next question?
No, I'm just writing it down.
Oh, okay. How do we feel, guys? Do we feel okay? Sorry if I messed it up or if I confused you guys there. All right, what's up?
Why aren't you like subtracting the two intervals? Because you're trying to find the area into two.
Well, look, notice that I split them up into 2. You see red and you see blue? What's in red, there's no reason for me to subtract. It's this area plus this area. So this area is the one in red here. And the one in blue, look, it's the top line minus the bottom line that gives me the height of that rectangle. And that's exactly what I did. Square root of x minus 2. Do you see what I'm talking about? Yeah, sorry if I messed you up with the calculator notation a little while ago. It's just that I'm just not thinking. I'm in autopilot. So because I'm in autopilot, yes, right there I was, because I was thinking of stuff that I got to turn in, and I wasn't thinking about this. But now I'm focused. I'm all in back. I said, it's going to get turned in when it's going to get turned in. I can't do it right now. Okay, so we're okay? All right, so I'm going to make sure not to do any more mistakes with the calculator. No, it's not. It's not okay. Well, I don't think by me making mistakes, those type of mistakes, you're more like, what is he typing? Why? So, okay, here we go. Look what it says here. This is the same region. It says find the area of the region in example 1 by subtracting the area of the triangular region from the area under the square root curve. Oh, okay. Let me read that again. Find the area of the region, example 1, by subtracting the area of the triangular region from the area of under the square root curve. Okay, do you guys see this triangle? Let me use a different color than this one. Let's use burnt orange. Do you guys see this triangle right here? Notice, so what it's telling me to do, let me highlight this in orange first. What it's telling me to do is to find the area under the square root curve. So look, I'm going to highlight it in red. It's telling me to do this. Find all this area in red, and then once you find the area in red, you're going to subtract the area in, I did a horrible job. Burnt orange. There it is. Now I'm doing a better job. Do you guys see what I'm doing? So I'm going to color code it. So here it is. I'm going to go area under the curve. So I'm going to integral from 0 all the way to 4 of under the square root curve. So I can say square root of x minus 0, but isn't it just better to just say square root of x? Yeah, this line right here, the x-axis, that's y equals 0, guys. So I could have said square root of x minus 0, but just say square root of x. And I'm going to subtract the area, and I'm color coding it, guys. Area of triangle region. No, because we're just going to do geometry. You can, which actually this is actually no, we didn't do it here. We could do an integral, but why would you want to do an integral when we can just do geometry? Do you know what I mean? No? Okay. This right here, you could, if you wanted to. You know what? We'll test it right now. If you wanted to, you can do 2 to 4 of whatever this is. What line is this? What was the equation? X minus 2? You could. But let's just do geometry first, and let's see if this is the same as the area of that triangle with geometry. All right, so here we go. Antiderivative of this was 2/3 x to the 3/2. We did that earlier. Do you guys remember? 0 to 4 minus area of that triangle. Well, let's see what that area of that triangle is. My base. What's the distance between 2 and 4? Or I guess 4 and 2. Yeah, 2. So 1/2 base times height. What's the height? No, the height is not 4. The height is 2 again. See, my y value down here is 0. The y value up there is 2. So let's see. This in red, let me put an equal sign here. And let's see what I get. Ready? I don't care about that 0. Well, I do, but 0 to any power is 0. I do care about that 4. The square root of 4 is 2. 2 to the third power is 8. 8 times 2. So I have 16 over 3 minus, let's see, half of 2 is 1, and 1 times 2 is 2. And then look at that. That 2, we said earlier, that was just 6 over 3. 16 over 3 minus 6 over 3. Again, I just get, and isn't that the answer that I was supposed to get anyways? Yeah. Yeah, go ahead.
So this is just another way
Another way to do it. Kyle was like, "Child, can I do integral of from 2 to 4? Yeah, you can. Antiderivative of x is x squared over 2. Antiderivative of 2 is 2x. And if I do this from 2 to 4, I bet you're going to get 2. Child, I don't believe you. What? Yeah, this area from 2 to 4 of x minus 2 is the area under the linear line. And the area under the linear line from 2 to 4 is that triangle. It should be this number, that 2. Because the 2 was the number for area under that triangle. The area of that triangle region. So let's see if it is. If I plug in a 4. So let me do the top minus bottom. 4. 4 squared. 16. 16 divided by 2? 8 minus 2 divided by 4. Yeah, 1/2. So I'm going to say 8 minus 0.5. Okay, that's the upper. Chop, I don't see it that being 2. Well, let's see. Minus. Let's do the bottom. 2 squared. Divided by 2? 2. And then 2 divided by 2? 1. All right, 2 minus 1. Did I do that correctly? X squared over 2. Guys, the antiderivative of 2 is not 2 over x. How come you didn't stop me? Antiderivative of 2. 2x. All right, so that changes that 0.5. 2 times 4. 8. And minus, this 2 is correct. And then 2 times 2. 4. Look at this. The 8's 0 out. minus 2 minus 4 is negative 2. So minus a negative 2, you just get 2, which is this number. Cool, right? Okay. How do we feel? We feel okay? Okay, yeah, I'm tired too. I'm making all mistakes all over the place. All right. You guys ready for this one? All right, here we go. For regions like these, notice this regions. This is a function with respect to what letter? Y. Notice x equals gy. So with these, we're not going to integrate with respect to x. We're going to integrate with respect to y. Notice this gap. That's a dy. Notice that gap. That's a dy. That's a dy.
And why is it a big Y?
It's a difference in y. It's like delta y.
Oh, okay. Instead of going like that.
Yeah,
Okay.
yeah. Well, I guess, yeah, maybe I should say delta y. Delta y, and then delta y. That's a change in y. Do you guys see that, guys? And then the height is this right here. So what is this height? F of this height right here is going to be f of y minus g of y. Child, why? Why is that the height? Why can't you say g of y minus f of y? Okay, let me do a number line. You guys ready? If I told you this is just a number line, that's negative 1, that is 5. What is the distance between these two numbers? It's not 4. 6. How did you do that? The rightmost number minus the leftmost number. So whenever you're integrating with respect to y, look, those are delta y's. I guess you can just draw a horizontal line. What's considered to be the top, quote unquote? The rightmost number or the rightmost curve. What's considered the left? What's considered the bottom? The leftmost curve.
Oh, okay.
Yeah. So what's considered the top? The rightmost curve. What's considered the bottom? The leftmost curve. This is when we're integrating with respect to what? Y. Notice that's a delta y. See, and we're just adding an infinite amount of rectangles, which turns that delta y into a dy. Cool or not cool? Okay. And by the way, what are my limits? Notice that the lower limit, it's a c value. It's a y, the lowest y value, and then the upper limit is the top value, the highest y value. Are we okay, guys? Okay. All right, let's do an example. Oh, look, it's the same curve. Yeah, I did that on purpose. All right, notice if I draw a horizontal line, it doesn't matter where I draw my horizontal line, this linear line is always on top, quote unquote. And Oyani, that's a demerit. The square root curve is always on bottom. Do you guys see that? I'm going to integrate with respect to y, so I need to find these equations in terms of x equals, because I need to find my delta y's. So let's see, y equals square root of x, and the other equation was y equals x minus 2. All right, here we go. Put a parenthesis on it. Squared. Chop y, because I'm trying to solve for x, guys. X equals y squared. That's this curve right here. That curve is x equals y squared. It actually continues like that, but that's fine. Are we still okay? All right, here we go. This curve right here. I'm going to move the 2 to the left, and then I'm going to write it in terms of x. X equals y plus 2. So this curve is x equals y plus 2. Are we still all right?
Yes.
All right. Integral. I'm doing it with respect to y, guys. These are dy's. That rectangle, that's a dy there, or a delta y. All right, here we go. Lower limit, 0. Upper limit,
4.
no,
2.
2. Yeah, it's a y value. All right, what's considered to be the top?
The y squared.
No, the y plus 2. Guys, horizontal line, the rightmost curve is the top. Draw a horizontal line. Okay, which one's the rightmost on that horizontal line? Y plus 2. Which one's the leftmost? Y squared. The rightmost is the top. You just told me. Look, we just did. Yeah, we just did. How do you find this height, this distance? Rightmost minus left. So the rightmost is the top. The bottom is the leftmost is the bottom.
Are you saying like the linear line is the rightmost?
Yeah, it is. Because the linear line on that curve, look, here's my rectangle. How do I find this height? How do I find the height of this rectangle? This line right here minus this line.
Because the linear line is the right.
The linear line would be considered the top. And then this is my delta y, which I'm going to respect to y. You guys see that? So y plus 2, y, that's the top, that's my top curve, minus, what's my bottom curve? Y squared. And then I close it with a dy. If you want to put that in parentheses, you can, and you don't have to. And no yawning. I saw that. I'm going to rewrite this. I just dropped the parentheses. I guess I'm putting it back in there. This is like your height. I put the parentheses just for conformity. And don't get mad when Delta Math or a textbook doesn't put the parentheses. This is your height. That's your width. dy, well, delta y technically. And then when I say dy, that means I'm putting it in an amount of rectangles. That makes sense, guys? Okay. I think we're good. Here we go. Let's do this first by hand and see if it's any easier. So, antiderivative of negative y squared with respect to y. That, negative y cubed over 3. What's antiderivative of y? What's antiderivative of 2? 2y. It's with respect to y. 0 to 2. Upper minus lower. You don't have to worry about the lower one. Negative 2 to the third power over 3 plus 2 squared over 2 plus 2 times 2. Let's see. Negative 2 to the third power, that's negative 8 over 3. 2 squared is 4, divided by 2 is back to 2. I guess you can also cancel just one of those. And then 2 times 2 is, Chav, that's not the same thing that we've been doing. Yeah, it is. Look, turn that 6 into, what's 6 times 3? 18? Into 18 over 3. Negative 8 thirds plus 18 over 3. What's negative 8 plus 18? There it is. Did we get negative 10 over 3 for the other ones? So there it is, guys. We just did, and now you just got to practice a whole bunch. We just integrated for the first time with respect to y. Is that good stuff or is that not good stuff? All right. Don't worry, we're not going to do things by hand anymore. All right. Let's just do some algebra really quick. So it says find the area of the region enclosed by the graph y equals x cubed and x equals y squared minus 2. We're going to do this two ways. We're going to do this first with respect to x. So they want this region. Here's the region they want. They want that in red, added with that in blue. I need that curve. I need that point and that point. Do you guys see that? And I'm going to color code it red and blue. Notice that. All right, real quick. What it says is a region. That's the only closed region. Every other region is not closed. It goes out forever.
Okay. But why did you hide some? What's the difference in colors?
Oh, because when I draw a vertical line, I notice that vertical line does not, it's the top curve minus the bottom curve all throughout there. And then as soon as I pass this point where they intersect, I notice I'm looking at a different curve. So I have two different regions. I'm going to have two different integrals. Yes, miss. Ask me.
Which one is the top?
Well, if I do it with respect to x, the top one is the top one. Yeah, look. Well, yeah, see, that's where, before we even get started, do you know how to even get this graph here? This is from in the opening up in the x direction. So you know that that's this. So would you be able to draw that without a calculator if you were given this? Okay, from your Algebra 1 days, let's talk. So if you ever see this again, which you will, you notice that the x is by itself. Well, x, it's a linear term, the x, and notice that the y is being squared. So if you see that, that means it's going to open up in the y direction. I mean, in the x direction, in this direction, whichever one is the one that's linear, it's going to open up in that, like that. So it's either going to open up to the right or to the left. If you have y equals x squared minus 2. So that's similar to that graph. This one opens up in the y direction. It's either going to open up or it's going to open up down. Now, maybe this is what you have seen before. So check it out. If I move that 2 to the left, x plus 2 equals y squared. And how do I get rid of that square there? Square root, square root. Now remember, y equals plus minus square root of x plus 2. So that's why they have this as y2 and this as y3. Let me explain. If I go y2 equals square root of x plus 2, that's going to create this part. Here's negative 2, because that's a horizontal shift 2 to the left compared to y equals square root of x. And then boom, so here's y equals square root of x, and then bam, like that. See? If I go to y3, and I guess I should change my color here, y3, and I go negative square root of x plus 2, because see, I'm doing the negative one now. Well, it looks like I'm below the x-axis. Do you guys see that? And that's what creates this right here. So see, this negative creates this branch below the x-axis. What's up?
If it's not too much, do you think you could add like just an optional dose of math, like making graphs?
Yeah, we can do conics. Do you know how to do ellipses and hyperbolas? Okay, never mind.
Is that in circles?
Yeah.
I remember like the circles and the rows and the peach and the.
I
Do-
remember that.
Do you remember? Oh, opens up in the y,
Yes, I remember that.
and then opens up in the x. All right.
I know I could tell you what those are, but I can't figure out how to like. If you were to give me one, I can't draw it.
Hey fam, are you still watching this video? We'll see if she watches it. I do. All right. That's algebra review. It's called conics. We'll do conics sometime. If you're an engineer, please make sure you are well aware of all the different models. So you guys are going to need them, guys. Maybe after the AP exam, we can have nothing but conics. All right. You guys ready? Type on y1, type in x cubed. On y2, type in the positive square root of x plus 2. And on y3, type in that one, the negative one. So I'm going to take my calculator. I'm going to click y equals. And y1, I'm going to type in x cubed. y2, square root of, what is it, x minus 2? Oh, yeah, x plus 2. And y3, negative square root x minus 2. I keep doing it. Sorry, guys. Let's do it. All right, here we go. You guys ready? Oh, actually, you know what? I should have just changed the window to this window. Negative 3 to 3, negative 3 to 3. Click window and put negative 3 to 3. And then y min, negative 3 to 3. Make it look like, there you go. That looks pretty. That's a pretty graph there. The lower limit is negative 1. I can tell that pretty quickly. Negative 1 to the third power for the x cubed is negative 1. And if I plug in a negative 1 into the square root of x plus 2, I get negative 1. If I plug it into the negative branch, the negative square root of x plus 2. If you plug it into the positive branch, you'll get a 1. So this point down here is negative 1. Do you guys know what I'm talking about? See how the equation says y1 equals x cubed? Negative 1 to the third power is negative 1. So I have that point here is negative 1 comma negative 1. If I plug it into this one right here, negative square root of negative 1 plus 2, you get negative 1 again. So my y values match. So that intersection point is negative 1 comma negative 1 for the intersection between the x cubed and the negative square root of x plus 2. I looked at it in the equation right here. I saw negative 1, and I'm like, oh, that looks like negative 1. But you could have also set them equal to each other, right? You could have set that equal to that and solved. Okay. The one that is not a 1 is letter C. Notice letter C is a little bit past it. Do you guys see that? So I'm going to tell my calculator to give me that intersection right there. I'm going to need it. Well, I'm going to need it. Yeah, no, I'm going to need it. So I'm going to go second calculate number 5. Enter, enter. And when it says guess, I'm going to scroll to the one I want. I want that one right there. Are we okay? Push enter. There it is, 1.2148623. Do you guys see that? Go to the home screen. I push X. I'm going to store, and they use the letter C, so that's the letter I'm going to use. I usually go down the alphabet, but I'm not going down the alphabet because I don't want to confuse anyone. So I'm going to store it in letter C. And there it is. That's my new C. So this is called the setup when you're taking the AP exam, and it's a calculator section. Okay, when you're taking any exam, regardless of whether it's AP or not, do not use calculator language. Y1, Y2, Y3, that's calculator language. Do not use calculator language. So when you're taking the AP exam, you're going to say x cubed equals, and let's see, which one do I want? I want the bottom branch and I want I want the top branch. X cubed equals the square root of x plus 2. And then in the bottom, you're just going to go x equals, and you're going to give me that number. 1 point, what was it? 21. 4862, and I'm going to put the arrow, and I'm going to store it like that to C. And now I can just say the letter C. So here it is. I'm finding this, guys. I'm finding this area. I'm going to color code it. Integral from -2 all the way to -1, and the top curve of that is square root of x plus 2 minus negative square root of x plus 2 dx. Does everyone know what I just did? No? I'm doing this part in red. What's the top curve?
Wait, no, where's your mark? Your upper.
-2, -1.
Why aren't you doing the other?
I'm about to. I'm good. I haven't done it yet. That's right. Upper minus lower. Top curve is square root of x plus 2. Bottom curve is a negative square root of x plus 2. Upper minus lower. We're okay with that?
Yeah.
From -2 to -1. -2 to -1. That -1 is an x, not the y. Okay. Here it comes. I'm changing my color to blue. Azul. Plus integral from -1 to C. There is my C value right there. So my reader and my grader should know that my upper limit is 1.2148662. What is this top curve? Square root of x plus 2. And I'm going to subtract this bottom curve, which is x cubed dx. There it is. I'm going to type it like this in my calculator. So I'll take my calculator. I'm going to, yes. Yes, but do I want to write Y1s and Y2s on my exam? Do not write Y1 and Y2. That's calculator language. They're gonna take points off if you use Y1 and Y2. You might be able to get away with it, maybe, if you say Y1 is something, but I don't recommend it. Yes.
Okay, quick question. When you subtract the negative square root x plus 2, isn't that, why do you do that?
Upper minus lower. I just did upper minus lower. That's the top curve, that's the bottom curve. Upper minus lower. This bottom curve is the square root, the negative part, negative square root of x plus 2. This top curve is the square root of x plus 2. Upper curve minus lower curve. For the portion in red only. And then once I pass -1, then the portion in blue is the square root of x plus 2 minus x cubed. That's for the blue one. But for the red one, it's the top minus the bottom. This bottom part, that's negative square root.
Oh, okay.
Do you know what I'm trying to say?
Yeah.
Like that curve
You're
is,
just trying to get that portion, right?
yeah,
Okay.
that's the bottom curve is this one, the negative square root of x plus 2. I think we did it up here. Did I already erase it?
Yeah, I remember.
Make sure. No, ask me, miss. Ask me. I'm good. Are you good?
Yeah, I do.
Okay. So here we go. I'm going to take my calculator. or maybe you're thinking of something else, which I guess I can address that in a little bit. Math 9 from -2 to -1. And which the positive one, where did I have it on? Y2 or Y3? Y2. Alpha trace Y2. I put Y1. Alpha trace Y2 minus alpha trace Y3. You know what? Maybe my laptop is messing up this video and it's not really recording. Maybe that's why it's doing hiccups. I'm going to add, hopefully, we'll find out right now. And then math 9 from -1 all the way to C. And now I'm doing, which one's the top curve? Y2? Alpha trace Y2. And then my minus Y1. With respect to X. And there it is, 4.21494. Maybe you were thinking this, Morales, and I just, maybe you were thinking like minus a negative and you'll have two of those. You could have done that too, if you wanted to.
Oh no, I would like that was you answered my question.
Oh, I did?
Also, that was another question I had, but
You could do that, yeah, you can do that.
no, but it's just what you answered my question. I was confused on what you minus, but it's because you want to get that. That's how you get area in that portion.
Yep. It would have counted. This would have counted also, guys. I bet you it would work. Let's see. Let's do that. I'm going to scroll up, push enter, go to the far left. I'm going to put a 2 in front of that Y2. Second, insert 2. And I'm going to delete the minus and the Y3. All right, let's see if that works. Yeah, it works. You could do that. Cool or not cool? Okay. We're almost done, guys. Do you think it would have been easier to integrate this with respect to Y? If I look at this, if I integrate with respect to Y, I'll do it in burnt orange.
Because you asked the question, yes.
Notice if I integrate with respect to Y, the rightmost curve, the x cube, is always on top, and the parabola is always on bottom, quote unquote. Does that make sense? So I could have done it like this. I could have said integral. And now I am going to need, well, the lower limit is -1 for the Y value, -1. But I do need my, this little, I guess they call it little d here. So I'm going to put little d on the upper, all right, guys, focus, on the upper limit of that integrand. And here we go. I need the upper, look, they already give it to me in terms of, well, actually, they gave me the right one in terms of x. But the y equals x cubed, I need to have x equals because I need to have it in terms of x equals. So let me do that really fast, guys. Y equals x cubed. How do I get rid of that that third power there? Cube root it, cube root it, cube root it. X equals the cube root of y. Do you guys see what we just did? Okay, so here we go. I'm going to zoom out. The cube root of y, because that's what's quote unquote on top, minus parenthesis, and then the parabola, they have it right here. X equals y squared minus 2 minus y squared minus 2 dy. Now I need to figure out what this is. I need to figure out what lowercase d is. So I come to the side and I'm just going to set it up. Chop, how do you set it up? Like this. So see how it says x equals the cube root of y? You're just going to go cube root of y equals y squared minus 2. Now, because you have a calculator, this is called the setup. Do you have to show the arithmetic to get the y value of where this is true? No. Use your calculator. You already have it. Here it is. There it is right there, this intersection point. So for those of you in computer science, you might find this pretty easy because you guys know about this already. Number 5, intersect, enter, enter, and then when it says guess, enter. You have to see the word intersection. You must say the word intersection. Do you guys remember when you guys were in computer science talking about pop and stack memory allocation? No, you don't remember? Do you remember the word pop, stack, memory? the way this works, the technical term, now I don't know, because I've been out of the game for a long time, but when I was in computer science, the technical term was called a register. So it's stored in a register, and that register is called X, and then if you want to recall that memory, like pop X, and then pop Y, or if you want to store the memory, then you're stacking it, stack, and then you can stack like stuff on top of stuff. Does that sound familiar? Yeah. See, so there it is. So this is called a register. Let's say if we want to be technical. If you don't want to be technical, it's like, oh, the Y value is stored in somewhere in the calculator. But it's stored as register Y. Now, maybe there's new lingo. I don't know. Maybe there's new lingo. Please fill me in because I want to be caught up with the current stuff. So right now, as long as I don't overwrite it, it's stuck as that my Y value in the calculator, the memory has that. Cool or not cool? So go to the home screen. As long as you don't overwrite it, that Y value is stuck in there. So I go Y. Child, where's the Y? Look for the green. In mine, it's green. I don't know what color in yours is. Alpha number 1. So on mine is number 1 and it's green. Do you guys see that? I'm gonna push the stove button, and I'm gonna change it to what letter? Little lowercase d. Well, in this case it's uppercase, but no big deal. So I'm gonna change it to that, and I'm gonna push enter, and there it is. That's that same value that I just had that I was looking at a little while ago, right? So I come back and I say y equals. Give me the number that you guys got. 1. Yeah, the most digits, the better. And then I put an arrow. And because they're using lowercase d, I guess I'm going to use lowercase d. And then, so this should, what's the word? See, I'm bad at English. Is it supersede or proceed or before? Like, what's the before one? Like, before I write this integral. This should be somewhere, write it somewhere before, and then this should be like below. Yeah, because when you execute code, it executes top to bottom. This, because if you execute this, it's not going to know like, well, what is lowercase d? So you should have this written somewhere before you write that integrand. Cool or not cool? Okay, now Chavez, how do I type it in the calculator? Guys, the calculator is just a tool. If you wanted to type Y's in your TI-84, you can, but I just think it would take forever because of the keystrokes. So look, I guess we'll try it real quick to take forever. Look, you could go math 9. What was my lower value? -1. And then I already have it stored as D here, so alpha D. And you could, if you wanted to, what's my first one? The cube root of Y. So I can go alpha Y and then put power 1/3. That's the cube root minus parenthesis alpha. What was it? Y squared. What's it? Y squared minus 2. That was it?
Yes.
Like that?
Yes.
I don't know why I don't like it, but that's fine. Okay. With respect to alpha Y. Okay, let's see. Boom. Look, we got the same. I think it took too much button pressing alpha all the time. You could just do this. You could just go math 9, -1, and then you can call it any letter, guys. Alpha D, and I can just say, this time I'm going to use the cube root function. The cube root of x minus parenthesis x squared minus 2 close. It doesn't matter. It does matter what you write on the paper, but it doesn't matter what you call it in the calculator. You'll still do it. Now, there is some discrepancy. I don't know if you noticed. Let me see. Look at that one and look at this one. 4.2149. So the first 1, 2, 3, 4 digits after the decimal are the same, and then the 5th digit is different. Do you guys see that? It doesn't matter. If you were to write the bottom one, remember the AP readers only look at the first 3 digits after the decimal, so you would have gotten it right anyways. It's just calculate the way it calculates. It's executing code, and after you reaches a certain tolerance, it says, "Here you go. Here's an answer." How do we feel?
How do both of them work? Like, I feel like that. Yeah, why are they just?
It's the way that it executes the code. It's just, that's all it is. It's executing an algorithm, and once it reaches a certain tolerance, it gives you an answer. I don't know what's the true answer. They're both good enough. So if you become a computer scientist, you can really understand, like, you know what I mean? So if you decide to go that route. How do you feel, Morales? Okay. All right, guys. We just have 2 more, but don't worry. These are going to go fast. This is how your delta math looks. There's a no calculator and there's a calculator. The no calculator is going to take you a while. So is a calculator is going to take you a while because it takes time to push buttons. This time they give it a name. See how they call it f of x and g of x? Know which one's which. That linear line is a linear line. So that linear line is g of x. And the parabola is f of x. All right. And then this line, this dashed line, is x equals 1.5. Find the area of the shaded region using a calculator. Okay, there's 2 regions. There's a region in red, and there's a region in blue. Oh man, I pushed the wrong one here. Boom, boom, boom. Do you guys see that? I need the intersection. We got to be definitive. You got to know that intersection for sure. That intersection happens at 1, 5. For sure it happens at 1. How do I know for a fact? If I plug in a 1 in here, 1 squared is 1. Negative 4 plus 9 is 5. If I plug in a 1, that one better be 5 also. Yep, negative 2 plus 7 is 5. So they intersect at 1, 5. Are we okay? All right. Ready, Kyle? Integral. Give me my lower limit, miss. No. We're finding it with respect to x. Lower limit? No. What's my x value here? 0. What's my rightmost value for the one in red? 1. All right, what curve's on top? F of x or g of x? F of x minus g of x dx. There it is. Height times width. Now I'm going to change my color to blue. Integral from, what's my lower limit? No. 1. I'm doing the one in blue, guys. What's my upper limit? 1.5. What curve is on top now? G of x minus, put that in parentheses, dx. There it is. Now I'm just typing into the calculator. This is for notes. Do not write this on an exam. I'm going to type this one into y1. I'm going to type this one into y2. So here we go. Calculator. Y equals, clear, clear, clear. What was my y1? I already forgot it. Negative 4x squared plus 9. What was my y2? Negative 2x plus 7. All right, there it is. Second quit. And let me look at it again. 0 to 1, f of x minus g of x. Okay, so here you go. Math 9, 0 to 1. Alpha trace. I think I put it in y1, so y1 minus y2, f of x minus g of x. Am I doing that right? Okay. Put an x here. Plus math 9, 1 to 1.5. And now I think I put it in y2 minus y1. So alpha trace y2 minus alpha trace y1. And then x. Enter. 2.5833333333. Math, frac, enter. 31 over 12. Try to avoid, I know some of you are going to do this, which is fine. I think it's fine. Try to avoid that line. I know it means that 3's keep going forever. I feel more comfortable with you writing out 333. All right, last one. Yeah, don't worry. Your activity is going to be simple because you don't have to do anything by hand. Everything can be done with a calculator. Okay, you guys ready? Okay, they don't want the answer. That the shaded region be the area enclosed by the square root of x minus 2, the horizontal line y equals 0. And the y-axis. Write an integral in terms of x and also an integral in terms of y that would represent the area of the shaded region. They don't want an answer. Well, they don't want a value for the area. They just want the integral with respect to x and with respect to y. So let's do the one with respect to x first. So these are all delta x's. See? Those are all delta x's. So here it is. I'm just going to do it with respect to x first. Should be pretty straightforward. Integral. What's my leftmost x value? What's my rightmost x value? 4. And it's this line here, the x-axis. So that x-axis is y equals 0. So you're going to say 0 minus, and what curve is this? F of x. But I'm going to go ahead and write the expression. So minus square root of x minus 2. Notice I put it in parentheses, dx. If you distribute the negative, that would be integral 0 to 4, negative square root of x plus 2 dx. Is everyone okay with how I got that? Okay. Say it again? Yes, you're allowed to distribute. There's a negative in front of that, right? And there it is. All right, here we go. In terms of y. Well, if I need to have it in terms of y, so y equals square root of x minus 2, move the 2 to the other side. Square root of x equals y plus 2. Now, how do I get this to be x equals? Square, square. Don't try to simplify it. This is simplified. A binomial with a square on it. Y plus 2, close it squared. Okay, here we go. I draw a horizontal line like so, just to figure out these rectangles. The rightmost is this. The leftmost is that. You don't have to whenever you're doing minus 0, but that's fine. I'm gonna put it. Integral. What's the lowest y value? No, not -3. -2. The y. I'm looking at the y values, guys. What's the highest y value? 0. Rightmost curve. Y plus 2 squared. And I guess you can say minus 0. You don't have to. You okay, Kyle?
Yes.
Are you sure?
Yes.
Okay.
How
Tell me.
How is it the right?
How is the what?
How is it the right mouse?
Which is the upper. It's the one in the first right, this line here. That's the leftmost. It is x equals 0 right here. I'll show you. Maybe you want to see it. Don't worry, I see you, Johnson. Remember, this curve right here is this curve right here. That's x equals y plus 2 squared. See, it's right there. This curve right here, the y-axis, that curve is x equals 0. I'm doing the expression y plus 2 squared minus that 0. And all that, remember, these rectangles, this is a delta y, dy. What's up? Oh, yeah, you have to have the differential. Without the differential, you don't have a reader. You must have the differential, guys. Now, I'm not going to say that sometimes we do look past it and still get the point, but most of the times we do not. It depends. So that differential is important. Your professor is not going to your professor, being around professors a lot, your professor would probably cringe if you do not put the dy in. And that's probably the right word, because he's probably going to be like, oh, you can't integrate this, you don't have width times height. Because this literally is like your width, and then this is your height of the rectangle. Remember what this means. Don't be a robot. This means you're adding an infinite amount of rectangles. If you don't have that dy, you're not adding anything. I mean, I guess you're adding infinite amount of heights, but you're not multiplying any areas. You know what I mean? So don't be a robot. It needs a differential. Width times height, width times height, width times height. Infinite amount. When do you bend? He bumped into it. Okay. There it is. How do we feel? All right. So you have an activity, a handout. It's all calculator. All you got to do is show me it's called the setup. Show me the setup, and then ask me if you are having questions with how to type it into the calculator. And we're good, guys.